We are trying to find this particularly horrendous integral from pi divided by 4 to pi for cos 2y dy. All right, that's pretty hectic, right? Let's make it easier. All right, what happens if you were just trying to find the integral of just cos of y? All right. Well, remember cos and sine are intricately linked, so it becomes a sine, and we get r plus c. Now, if we differentiate this value, okay, we go sine back to cos, and you don't see that there is like it doesn't go from uh, cos to sine. When you differentiate, you go down. It doesn't end up being a sine, so there's no negative. Another way that I like to remember this is this little acronym that DC is worse than Marvel. So when you differentiate a cos, you get a negative. And then when you integrate a sine, you get um, a negative as well. So DC is worse than Marvel Comics, right? That's how I'm going to remember it. So in this case, it's just going to be a sine and there is no negative, okay? And then we get our plus c. So the next question is, what happens if I integrate cos and I stick a 2 in here? Okay, I can do the same thing that I did before, all right? I get it being a sine and I keep the brackets the same, okay? And then what happens if I was to differentiate that to try and bring it back to the original one? Well, I'd use the chain rule that 2 would come out the front and I get a 2 cos of 2y. And hang on a minute, that doesn't equal to our original value here. So because of that chain, we're going to have to divide by 2. And so the final result that we get is going to be this. So let me write it out properly now. We've done the warm-up exercises. We can get to the real question. We can say that this is sine, but now we're going to have to divide by that too. Right. Now, I like to do something funky if there's a constant. So in this case, it is 1/2. I can bring that out the front of this because it's a constant. It doesn't affect the gradient at all. So it makes it a little bit easier. And now we substitute this pi, that value of pi, into the value of y, and then we say minus, and then we substitute that value of minus pi on 4, okay? So let's go ahead and do this. It's going to get a little tricky. So we can say sine of 2 pi and I'm also just going to keep that 1/2 out the front of sine of 2 times by minus pi on 4. Okay, so it's getting pretty squishy there. But what we can do is we can draw a unit circle to make this a little bit easier. I'm just going to simplify the last bit for you. Now that 2 is at the top, that becomes minus pi divided by 2. Okay, so when we draw a unit circle, just make our lives a lot easier, right? We can crawl for the x-axis and we can touch the sky for the y-axis, okay? So in the first case, we're going all the way around 360 degrees to pi, and we end up here. And that is at point 1 and 0, right? So we're 1 across, it's a unit circle, it's only got a radius of 1. And so we can say that the sine of 2 pi, which is the y component, is equal to 0. The next bit is, what happens if we go back right, by 90 degrees. All right, we end up at this point, and that is 0, but a -1 down. So I guess that -1 becomes this value here. Okay, so now you've got the values of your sine. You can write it out, and we can say that is equal to, or 1/2. Okay, now instead of saying sine 2 pi, we can say that's equal to 0. And then minus 1/2, and then in this case it's -1. Okay, so that makes it easy, that cancels out. And we've got -1 times by -1, that becomes a positive, and that is just going to be equal to 1/2. And that is our final answer. So if you've got any questions, let me know. I'd love to help. I've got so many practice questions here for you on my website. The link's down below. You get really good if you do them all. So give it a shot.